If you look at this question, there is totally no circles. So no circles means you don't need to think about properties of circles. So most probably it will be purely similarity and congruency. So if that is the case, right, if I just look at it like second part, px is equal to qx. If I'm going to prove same length, I'm expecting congruency on the second part. Okay, so that is the idea. But then for the first part, we need to prove isosceles triangle. So the feature of isosceles triangle can either be two length. If I can prove two length, then I can prove that it's an isosceles triangle. So I can also be proving two angle. So you got to see for yourself. Would you try to aim these two length? Do you have sufficient to prove that two length? Or do you have sufficient property to information to prove these two angle? So either one of them will enable you to prove the isosceles triangle. So you should have this in mind first. Am I going to prove isosceles through length, or am I going to prove it through angle? So that all depends what information are you given. Okay. So if you read, right, right, there seems to be a lot of information. We got some same length. So do you realize this part is same length? So they tell you that this is the same length. So what is the implication? That means, right, these two angles will be the same. Okay. And then after that, I got another same length here. So how will these two help me to prove the isosceles triangle? Okay, so I think the red angle is quite easy. The red angle can be like a theta. Okay, the blue part, I'm going to form congruent triangle. I'm going to form a congruent triangle. So if these two blue triangles are congruent, if the two blue triangles are congruent, so if I can successfully prove that these two triangles are congruent, then this blue angle will be the same. So this blue angle will be the same. And that enable me to get theta minus k, theta minus k. So the theta minus k is the base angle of AXB. So I'm using the angle portion. So I'm using the angle portion. So I'm trying to prove XAB equal to XBA. So I use this to prove the isosceles triangle. So while I use this, right, I actually got two components. I got the red component, which is rather simple. So if you want to explain the angle theta, it's very simple. The blue one is the one. How are you going to prove the congruency? Okay, so that is something for you to do. Okay, subsequently, I'm going to go to the second part. So remember, if you're at the second part, whatever you already have for the first part is applicable. So we already got isosceles triangle AXB. So everything has been set up. Then we move on to part two. So part 2, we are supposed to prove this. So this is somewhat here. So I'm going to prove another congruent triangle. So in order to prove this, right, I'm going to prove that triangle AXQ is congruent to triangle BXP. Because if I can manage to prove this congruent, then QX will be equal to PX. So mentally, you got to run through what are the available tests and what will you already have. Okay, so that is your challenge. Okay, so right now I gave you an overview. So right now is how are you going to lay out your explanation if you understand this idea already. So you need to spend some time writing out for part 1 and part 2.